Hello. Testing,
Hello.
testing.
Who am I hearing?
Yeah, I can hear very well.
Hey. It is super cold. It is super cold. It's time. Let's get started.
Okay. So,
Yeah.
do the intro, do the intro. Can you?
Pascal was sharing that just before. That's why we're just starting right on time. This is the 6TISCH working group meeting. I'm sorry? Before we get started, allow me to remind you the note well, which applies to this meeting as it applies to any IETF meeting. If you know of any IPR, you have to disclose it, whether it's yours or not. Please read the slide. If you have any questions, ask your favorite AD or work group chair. As a reminder, we are taking minutes. The meeting is being recorded and the presence is logged. Taking minutes, Dominique has agreed to be a note taker. Thank you so much. Can we have a second note taker in the room? Somebody volunteers?
Sorry for the link, it's obviously 103, right?
Yeah. Joshua, could you be a note taker? Would you mind being a second note taker? Would you mind backing up Dominique? Jabber scribe. It's now with me, Teco, there's really not much to do. Anybody? Marisha, could you be Jabber scribe? Thank you. Yeah, administrative. Oh, yeah, I have it right here. So this is the link to the Etherpad. The same link that I sent by email, the same link that you have in the agenda. Remote participation is possible through over MeetEcho. For the JavaScript, I recommend you just connect over MeetEcho. Mailing list meeting materials will be published. All the slides are online. I just updated the security slides that Marisha just sent. Otherwise, all the slides have been up for a number of hours now. This is the agenda that we have prepared. We have 105 out of 120 minutes scheduled, so we have a little bit of buffer time here. Let's try and finish 15 minutes early, if that's possible. So we're into the first element here, intro and status. Blue sheets, can we? Yeah, I think they're there. So please put your name, note well, scribes, agenda. I'll go to the agenda bashing right away. We'll start by some introduction. We'll then go into the chartered items. Pascal will give an update about the 6TISCH architecture document. The goal of this presentation is to prepare for workgroup last call. We put the goal here so it's very clear. Charlie Junana will then go through the 6-stop protocol draft, although this has been published a couple of days ago as an RFC. We'll then go through a big section about the MSF, the minimal schedule functions. Simon will introduce the work that we've done on the update. And then we have two presenters that will talk about its performance. So we have Yasuyuki Tanaka, who will talk about a simulation campaign that we're conducting on this MSF, as well as Tenfei will then talk about the experimental campaign that is ongoing. The goal here is to gather data from or input from those different campaigns in order to make the draft better. After that, we'll go on to the minimal security draft that Marisha will be presenting. I understand you pushed an 08 just this morning, and so you'll be presenting 07 and clearly highlighting the 08. Please don't assume everybody has read it. And then time permitting, we'll have a presentation by Simon Duquenois about a new draft on robust scheduling, a proposal to make it more robust against jammer attacks. And I'll include very quickly talking about the fragmentation design team, and then we have a little bit of time for any other business. Before we get started, is there anybody raising some issues, something you want to see added, removed, changed in this agenda, this slide and that slide? Please raise those issues now. Okay, I hear nothing, so I propose that we get started with our agenda.
Okay.
So since IETF 102, there's been a number of good news for this working group. Obviously, the biggest news is that we have RFC 8480, which was published. So many thanks to the author, Chavi, Chin, Thomas, many thanks, and this is actually a great achievement for this working group. Another achievement which is linked to the work in this working group, which we actually kind of pushed to 6LO because that's where the work belonged, but it was identified by the 6TISCH architecture, is RFC 8505 2B, because it's still in the Auth 48 queue, waiting for some people in this room to do something about it. But yes, this RFC will be published very, very soon, and hopefully before next week, where we'll discuss it at 822.11 for applicability in Wi-Fi. There is also work which has started in an American standardization body, which is called ODVA. ODVA is working on industrial automation. They have this common industrial protocol, CIP, that works over Ethernet and IP. And they are considering applying 6TISCH for their low speed automation. And so transforming CIP as it stands today, which is TCP based and possibly a large payload in the frames, trying to reduce the payload a little bit to make it more 6TISCH friendly, and looking at what it means to have UDP co-op as opposed to TCP underneath. So they are doing this work, and I've heard about a number of experimentation in a number of companies on 6TISCH, and so far they're pretty happy with it. And then, last but not least, we have interesting news from Thread. So Thread is a standard which builds a stack which is kind of similar to 6TISCH. They have 6LoWPAN, they use the 15.4 MAC and 5 underneath, but they are designed for used in-house. It's home automation thing. And now they are looking at whether they could expand their scope into commercial buildings, which requires a whole new set of scalability and routing quality, etc., which they have to prove that the current version of Thread is capable of any of that. I have in mind that if they kind of need something which is a bit more scalable and reliable, they could converge a bit more towards 6TISCH, but we'll see. I've started this discussion with people at Thread. I'm not intending Thread officially, so but have had that discussion already to start with. So these are basically the news since IETF 102. What you really sense is, compared to the first year or two at 6TISCH, we are really nearing the end where actually we deliver something and people start using it and including it, which is great news for this working group. There's also work, as you know, 6TISCH is as much a group that builds an architecture and pushes work elsewhere as it is a place where we do some actual RFCs. So we do actual RFCs, but we push at least as much work outside to complete the architecture. And so a number of our drafts are progressing and progressing well. So we've got a draft Vatane and draft Tuber fragmentation, which are now both draft IETF. So the fragmentation, which is part of our architecture, is now a work group document at 6LO. Neighbor discovery, it's a bundle of 3 drafts. One of them, like I mentioned, the first one is going RFC 8505, and the other 2 are nearing work group last call. I mean, Backbone Router will do the last call now, and APND is very close to there. There is this new interesting work as well, which is, Charlie, it's in last call now, the deadline. So all this is really getting near completion. So that's basically the feeling you should get from about everything we are doing. We are nearing completion. At Troll, we've pushed a number of interesting topics, and one of them is the DAO projection, which enables the root to actually push some routes inside the network. We've got the unaware leaf document, which enables a leaf which is not Ripple aware, which doesn't know how Ripple operates, to use 6LoWPAN neighbor discovery to ask routing services, Ripple routing services, from the first 6LR. That means that in 6TISCH now we can have nodes which don't participate to Ripple, but still get the packets routed through Ripple. And last but not least, we've got this draft Richardson enrollment priority. It's part of the priorities we have discovered that building large 6TISCH networks is when you've got this node which wants to join a network and there are multiple networks around, which network should I join? What kind of criteria should I find in the beacon so I can find not only the right network, but possibly also the best future parent in that network? So this is what this work is doing. And then we've got minimal security, which we'll discuss at length, I guess, Manisha. So I won't say much, but it's nearing completion as well with this dependency we have on COSI, on a score. Okay, that's pretty much it. So we'll keep the. Okay, so news from the architecture, it's a white whale. It's basically the document which sustains and explains the whole work that we are doing. So this document has been kept alive and following what 6TISCH has been doing across all those years. And now that we are reaching completion of everything we wanted to do in there, the discussion for today is whether we're ready to publish it. So there are two goals in the architecture document, and like I said, with the underlying idea that it should follow the work of the working group. So it's also an introduction for everybody joining the working group. Where are we going? What do we want to do? Well, the architecture was supposed to help people figure that out with one-stop document. You have two steps. The first step is the high-level architecture that Ralph Tromms asked us to build. At some point, Ralph reviewed this document. We almost made last call and wanted to publish several rounds of it. Ralph told us not to do that, to wait for the completion of the working group to publish the document. He also told us that he wanted to isolate the high-level architecture from the more refined components and how they work and what they do, which is what we did at the time. So the document is still structured this way. You've got section 3, which is the high-level architecture. And then, so some people may just stop there. And some other people may want to go deeper into what are the RFCs that we use, how are they positioned with regards to one another, how does the whole system work in finer details. So we have this section 4 that does that as well. So these slides were made for draft 15, which was published last month. But as it goes, Thomas just made me a great review of the document, so I just published 16 before this working group. So Thomas, if you look at the diffs, you will find basically what you found. So we have a 16. I did publish that 16 because since I had in mind to go and do the workgroup last call on the document, I thought let's do it with Thomas' review included, as opposed to find it a second time. So I did 16 as a cleanup version of 16 or 15. So because 6TISCH focused on the distributed operation, obviously the architecture has more details on the distributed operation. We still have some words on the centralized operation, which is enabled by the Mac, but we didn't work in this working group at all on the centralized operation and on, we mentioned PCs, etc., but we never say how the traffic engineering flows work. So it's obviously much higher level. It's just position, but not done. This was what we wanted to do. This was the charter we had. So because we are nearing completion and all the components are now in place, my suggestion is to go for workgroup last call now. So we are done and we don't overlay with the workgroup last call of minimal security or MSF, right? So basically we have the three main elements: MSF, minimal security, and architecture. And we don't want to have a same window of time for the various last call. We want to make them in order. So suggestion, if just depend on discussion MSF, but is to do the last call for architecture now. So we do MSF and then security. And that's pretty much it.
So I had a question. Sorry, I was answering an email. You might have said so. You expect there to be little changes to MSF and minimal security that we can publish this now, or what do you want to do? Or you want to wait before publishing this?
Basically, what I
What are you
want to
asking?
do is have different windows of time for all three.
Okay.
And now it's just a matter of the group to decide an order.
Okay.
This one is ready. It might not be the one that we want to publish first or workgroup last call first, but if the other ones are not fully ready, why don't we do that and do the workgroup last call for that one, while the authors of the other two are completing and polishing their work. The point is, for the level of details that the architecture needs, we know enough about MSF and the minimal security to describe it at that level in the spec. So I think the spec is okay. Obviously, the authors of the two drafts can check the text and give us feedback as part of the last call. But I don't expect that either minimal or MSF will change so much that whatever we have here after the last call is changed, right? So we can do it in any order. That's how I see it.
George.
A following up question from George from EMT Atlantic from Thomas. What if new drafts or new ideas will come to this 6TISCH tomorrow? How are we considered to integrate in this architecture, or will it be like separate?
I mean,
I thought architecture should have like all the components of the 6TISCH working groups.
we had a story. We wanted a full story, which was a minimal story, if you like. And we think that our story is complete.
Okay.
Now we can write a second book, a fully new story. But we had in mind a certain story for which we did a number of charter items. And we have this story complete. So we don't want to reopen that story. Maybe do another story, but not reopen that one. So if somebody wants to work on 6TISCH over foo, maybe it's called 6TISCH, maybe something else, but that's a different story. That's interesting. We want that to happen. It's not the 6TISCH architecture anymore.
So what I would recommend, this is Thomas, what I would recommend is that the authors of, in particular, MSF and minimal security, read the draft and provide some feedback, making sure that the text is, describes their solution well, and maybe also the, RC 8180, just to make sure that it represents what their drafts are.
Sure. I mean, everybody there in the workgroup last call is supposed to.
Yeah.
But those
But we can
particular.
formally ask those people to do this, and then we'll have 3 reviews coming in, and it will lower the risk of this being out of sync, which I don't think it is. But okay,
It's terminology as well.
exactly. What do we want to do with terminology? Do we push this at the same time as the architecture draft? Okay, this makes sense.
Any comments, objection?
Any comments? Yeah.
So let's see at the end of the meeting in which order we do things, right? But basically this one and the terminology are ready for workgroup last call.
Any comments before we move?
Yeah, Suresh Krishnan. So one of the things is like I was thinking is based on the IESC statement on the support document stuff. Like, do you think we can consolidate some of these documents, like terminology? Can we put it along with something else? For example, the architecture. I don't know, but just think about it if it makes sense or not.
I mean, if that helps you, why not? There is no objection at all.
Right. So
it will help us if we do it just because of the informational reference. So if the terminology is part of the standard track, because architecture, important. Michael, we discussed that a little bit, but so this architecture is very like the .NET architecture, and I was surprised that Lou called for a standard track document, and he explained it's not because you've got Must in there, it's because it has this exposure to other SDOs. And I said, well, that's exactly the same thing. We've got the same exposure with IEEE. So if he justifies and is correct that it should be standard track, then this document should also be standard track. So I changed it to standard track, but wanted your confirmation.
that's fine. So will you shepherd this, Thomas, or?
I think
I
it's
can,
Shweta.
Okay, so just like spend some time, put it in the shepherd write-up why you think it needs to be standard track, and that's enough. Like, so it's pretty much the chair's view of the working group. Just tell the working group to as well, and see if there's anybody has issues with it. But I'm fine with it personally.
Okay, so let's write down in the minutes for me to shepherd document and
Can I have a need here?
One second. And your recommendation is to roll in terminology within this draft, and so make it one
So
document.
the question is like, would somebody need the terminology without the architecture? That's how I think about it, right?
Yeah.
If the answer is yes, keep it separate. If not, put them together.
Yeah, I think they're both like wrappers around the work, and they're both contexts. They have the same function. You would read both at the same time.
Right. That's
Listen, actually, you will have internal pointers as opposed to external. The neat I wanted to point on is that actually you have my name on it, but there are like 10 authors.
Yeah.
And so we decided to follow the rules, like, put the contributors in the end and the editor on top. I would be very happy to put everybody on the front page, but you have to tell me that.
No.
And the other thing is Thomas is a co-author.
I'm not going to tell you that.
I'm not a co-author.
You are. You
Yeah.
gave me text long ago, so
Yeah.
you're still on the author list. And that's why long ago, when we did the first attempt to agree for this thing, we asked Shweta Bandari to be our shepherd, so we don't have this duplication of hats. So you have to sort that out. I mean, it's not.
That's fine. If you want me to get another shepherd, that's fine too. But I can talk to Shweta. It's not a big deal.
Officially, she's still the shepherd.
Okay.
No,
but of one of the documents. Right?
On the architecture, yeah.
Right.
Yeah. Well, the other one is just like a collection of words.
Right. So that's fine. So tell me when to go. And
I mean,
if you want to shepherd it, if Suresh doesn't have a problem with you being slightly co-author, then I'm perfectly happy.
I haven't touched. Yeah, well,
he's not the editor. I don't have an issue personally, with
let's
you
do it this
doing
way.
it.
It will
So
be easier. It will be easier. It will be more
right, and I really want somebody who's they're involved in this, unless there's a real conflict of interest. That's really the reason why somebody doesn't want to be shepherd on the document they're authoring. But he's not. If he's not active in there, really shouldn't matter.
No, I don't see a conflict of interest at all. I mean, this is not contentious at all. Thank you. Anybody wants to raise something before we move on about this document? Okay, let's hear nothing. Let's move on to the. You had it almost there. So Chavi, I think you can hear us. Can we hear you?
Yes. Do you hear me now?
Yes, I have not anything that works. Great.
Do you see me now?
We-
Okay.
Yeah. Okay. You're on, Chavi. We hear and see you.
Okay, great. So hi everybody. I'm gonna present the latest steps that we had on this 6TISCH protocol. Can you go to the next slide? Yeah. So the status is that it was already published as RFC, the 8480, on the 5th of November. So that's very good news for us. We did in the last 3 months some reviews, and we follow the indications by the RFC editor and IANA editors. And I will detail maybe for me the most important change that we had to do, but I want to thank especially to Suresh for following up with this, to Pascal and Thomas as well to follow up, and also the editors, Line and the IANA editor, Amanda, that did a really good job on this. The changes, there were mainly minor fixes, typos and some grammatical things. But then there was a discussion that took some time to solve. It was related to section 3.4.7, where there's a sentence that refers to a response to a return code in a 3-step transaction. And it wasn't clear whether this return code was applying to the requester or to the receiver of the transaction. So we had to rephrase this a couple of times. So we end up with the following text you see here. And maybe here is a little bit out of context, but if you read this section, you will find it now very clear, I guess. And I think that's it. So we are now at the end of this draft, and I hope it's complete now.
Yeah, thank you, Chavi. We did not know that this would be published in time for Bangkok, so that's great. Any questions about this before we move on? All right, thanks, Chavi. So as Pascal is playing with the the PDFs. So we're going to move on to a large section about MSF. A draft written by Tengfei, Alicia, Chari, Simon, and Diego. It's a large, it's a 3-step process because we'll have first. We still hear, I don't know, still hear Chari. We start hearing Simon. An introduction by Simon Duquesnoy about the changes that were made to the set, and then we'll hear about Yach and Tengfei with the evaluation of the performance of the solution. So Simon, if you do hear us.
Yeah, I can hear you. Can you hear me?
Perfect. Yeah, perfectly.
Yeah.
The slides are up. They're yours.
Okay, great. Yeah, thanks. So since the last IETF in Montreal, so the draft was adopted. So we had this MSF version 0 published at the end of August, and then we just published a new update, MSF version 1, just before the cutoff for this one meeting. And what's new in that new version is basically no new content. But instead, what we've done is that we've collected all the open issues that we had from the 6TISCH mailing list and from, if you go to next slide, by the way, you can go to next slide. Yeah, thanks. So from the 6TISCH mailing list and our GitHub, internal GitHub issues, and we have all of them into a new section in Appendix E, which is a temporary appendix with all the pending elements. Next slide. Thanks. So we have categorized the pending issues as security, performance, and editorial. So editorial are obviously quite minor, so it's just like terminology, etc. Performance, we have a large number of performance open issues, and many of them actually came from what you're going to hear next. From Yach and Tengfei, so the evaluation in simulation experiments. So we are going to work more on them. I'm not going to detail the performance issues here. Then unless there's a request. And then we also have security issues, in particular one, which I'll be talking a little bit about maybe here. I think it's a sensitive issue. So it's at joint time, because we have the autonomous cells now. There is a possible attack where a malicious pledge could drain resources of a joint proxy, because with the autonomous cells, nodes have to add new cells whenever they have new neighbors. And so if you're malicious, you could have lots of malicious pledges, and you put them out there just to drain resources of JPs. So that is something that needs to be discussed more. How do we prevent that? Like one obvious solution could be to have the joint traffic not go in the autonomous cells, but go in the minimal cell instead. But that will come as well with the performance degradation. So next slide, please. So in summary, sorry.
So this is Thomas, one clarifying question. So the issue is that the joint proxies are sending enhanced beacons, making the pledges aware that they exist. The pledges have their MAC address. They calculate the, how do you call them? The rendezvous cells to which the autonomous cells to which the pledge is listening. And so there can be a denial of service attack by just sending a data frame on every one of these cells that are showing up. Is that accurate?
Yeah.
And you basically starve.
That's correct. Memory on the
Okay. And so
memory and schedule.
This is similar to you have a radio receiver and you just continuously speak to it so that it cannot receive anything else. It's essentially jamming, right?
It's a bit different though, right? Because here you're taking up resources on the node's schedule. Yeah. Not on the air.
Yeah. But if you're doing this, that impacts stays, I believe, at the pledge, because Marisha is going to talk about it, but there is a mechanism by which the pledge does not relay any bogus join requests.
That's correct. It stays at the pledge.
Could you? Sorry, I'm asking Marisha to.
No.
Okay.
So I'll discuss this. This is Malaysia. So I will discuss this mechanism in the presentation. I guess you were thinking about the joint proxy, not the pledge.
Yeah, sorry, excuse me, joint proxy, yes.
Oh, yeah. And that stays at joint proxy, I agree.
Yeah.
No.
Yach, did you want to say something?
Yeah. Can you hear me?
Yes, perfect.
Okay. So yes, 6TISCH from India. The issue here is that the joint proxy needs to install autonomous cell of the pledge. So when the joint proxy receives the frame, the packet for the malicious pledge, the joint proxy will install an autonomous cell to the malicious pledge. That's the consuming the memory on the pledge. No, sorry, the proxy. This is the issue.
I see. So it's thank you, Yach. It's the opposite issue, right? The joint proxy fills up his schedule with cells from the pledges, potentially blocking other cells. Do we have a proposed change to that? Because I have the draft here. There's no proposed change. Do we have any proposal, or is just an issue that we're flagging? If not,
so I would have two. I have two proposals.
Well, this is a militia. A no-brainer would be just the downwards traffic. The downwards traffic goes into the minimal cell, and upwards traffic goes into the autonomous cell, ARIC cell for the joint proxy. This would be a no-brainer, but we can discuss this further.
Okay.
That's the most
Just
obvious solution.
Just two little comments is usually you limit the number of buffers that can be used for a certain purpose, so you don't starve for the rest of the traffic. But then the attack is if the attacker uses all those buffers, then a normal join cannot happen, right? So you leave the traffic the way it is by limiting the number of buffers, but you starve the newcomers.
This is militia again. So, I mean, this depends on how joint proxy is implemented. So, I mean, right now we have two options after the working group last call. We have a stateful and a stateless option. In a stateful option, the joint proxy will typically keep a couple of entries for the pledges, say 3 entries for the pledge to join through it. And with the stateless option, there is no such a thing. It just forwards with all the state that it needs to keep into the onwards to the JRC. Okay. And in terms of the neighbor cache that you're probably referring to, in case of stateless,
I was talking about the cells that you allocate just for accepting those calls.
So this is an ARIC cell. So this is at the joint proxy. This is one cell. So it's not.
But if a malicious guy starts using all the possible
it's a TX.
it will starve the guys who want to join because he will jam like a physical jam just those particular cells. It's just don't spend too much on it. It's just
It's a TX cell, right? Not an ARIC cell.
Marisha says yes. I propose that we continue the discussion on the mailing list, but yeah, I can actually see in the draft that there's a proposal a bit lower, but let's continue the discussion on the mailing list. Simon, do we switch to the simulation results?
Yes, you can go ahead and switch. Thanks.
Thanks, Simon. So yeah, back to you.
Hello, I'm 6TISCH. I'm going to talk about the result, the lessons I learned from the simulator implementation. Maybe that's so. Now to the next slide, please.
Next slide, please.
Okay. So to begin with, I'd like to introduce the 6TISCH simulator itself. So we've released a new version yesterday, the version 1.1.6, and it implements almost all protocols which you need to simulate 6TISCH network behaviors. It includes the ripple, trickle algorithm, 6-loop fragment, and fragment forwarding. And also it supports RFC 8480, this the 6-hop protocol. So the simulator supports the 6P fully, so you can use the 3-step transactions as well as the 2-step transactions. And you can simulate the secure join, and the simulator tries to follow the minimum configuration RFC 8180 as much as possible. Of course, it supports the TSCH, and the simulator, the MSF, is now up to date to the latest version of the draft. The next step, please. So here the typical use case of the simulator. When you come up with the idea, then evaluate the idea with the simulator, because iteration with the simulator is much faster and easier than with the real hardware. So when you get the result, you can share them with others, or if you see the idea is good enough to implement, so you can test it with the real physical hard devices. So you can run the simulator on a computer cluster system. So in fact, I'm usually use our institution's the cluster system to run the simulator. So you can use hundreds of the CPU cores to run the simulator in parallel. And also the 6TISCH simulator implements a radio propagation model called the pistol hack, but also it supports use the connectivity trace, which you obtain from the real deployment or testbed. The connectivity trace in this context is that the link PDL and RSSI measurements of all pairs of modes in the network. So 6TISCH simulator can use that measurement instead of using the radio propagation model. Then it can reproduce the radio environment, the real radio environment of your deployment site in the simulations. This is very powerful, and you will have the more realistic result. Next slide, please. So that the next slide is kind of the future works. The left-hand chart is from the paper titled "The Simulating 6TISCH Networks." This shows CDF of how much time it takes for a mode to get synchronized. So there are two lines. One line is the result of the simulator. The other is the result of the OpenWFN implementation. As you can see, these lines are almost identical, which means the simulators simulate the actual implementation well. So we are planning to conduct further performance comparison with the 6TISCH stack implementation. The other thing is the project SODA. So now we are building 6TISCH evaluation solution using the testbed and using this simulator. The SODA is the project name. So if you're interested, please check the paper shown in this slide. SODA 6TISCH Open Data Action. Next slide, please. So from here, I'm sharing the lesson I learned. So these two are, I think, the more important than others in terms of the performance impact. So during the preliminary simulations, I saw only a few or no dedicated cells are allocated, even under heavy traffic load. So I looked into the log file and found that the algorithm for the dedicated cell allocation doesn't work well, the optimal cells. So as a result, again, even the heavy traffic load, mode tend to have only the autonomous cells. This means that without they don't have the dedicated cell. Then eventually, mode have more incoming traffic than it can handle, than it can forward. Then TSQ grows. Then it runs out of memory for TX2. It starts dropping the incoming packet. So obviously, this impacts on the reliability, and I think we need to work more to harmonize the algorithm with the autonomous cell. Thomas, comment?
Yeah, I had a question. So, you're saying that with MSF1, which is, if people remember the kind of the mix between the old MSF0 and ASF. So now we have nodes has autonomous cells, and then after some time they can add a dedicated cell if there's enough traffic. And you're saying that that switch is a little bit too slow, that the modes are using autonomous cells a little bit too long, to the point where
too long, and sometimes it cannot allocate a dedicated cell, even if it needs the dedicated cell.
Why would it not be able to?
Okay, so I'll explain. So at first, the mode had only autonomous cells, and sometimes they have collision on the autonomous cell.
Mm-hmm.
Once the collision happens, the mode needs to start the retransmission algorithm and perform the backoff wait. During the backoff wait, the cell usage ratio of the autonomous cell goes down, which prevents the algorithm from triggering the dedicated cell allocation.
Okay, so would you say that this is a misuse of the backoff wait, that we're backing off and cutting ourselves from using, or not accounting well for that usage? Is that the idea?
Yeah, I think the counting the usage need to be improved.
Okay. Okay.
Thank you.
So just for clarification, what is your traffic pattern going on? Is this bursty traffic? Is this continuous traffic? What are the modes? How are the modes producing data?
Oh, this data?
Yeah. Are the modes producing data periodically, or is it
periodically? Yeah. Thank you. And also, I found the frame-pending bit feature. This is introduced to handle. Oh, okay.
Yeah, I'm sorry. Before you move to the next
point,
yeah. Here you have written numcell hardly reaches lim numcell. What do you mean by hardly? The term hardly.
It's a hard. Less chance to reach. The less chance to trigger the dedicated cell allocation.
So hardly means it redoes it, right? Because when you say hardly, sometimes people understand never, but it's always, right? It's very often
okay.
a minute. Is it?
So, sorry. Under heavy traffic, it won't. Actually, we need more simulations. But in a heavy traffic load, under the heavy traffic, the numcell use doesn't reach the threshold.
Okay.
So let's discuss further on the melodies. And the other thing is the minor thing, but the frame-pending bit feature is introduced to handle the transient, the bursty traffic. But actually, this feature could cause the bursty traffic and make the situation worse. So that the situation means the collision, the chance of the collision. So yeah, again, I think the scheduling algorithm itself we need to improvement. So next slide, please. So I already sent the other the many comments, including the what Simon pointed out. So you can see the other comments. They are found on the working group meetings archive. They're the link to the relevant threads. And now we are evaluating the latest MS implementation with the new release. And once the result is ready, we will share it with the working group. So next slide, please. So I think the conclusion of the presentation. So again, to me, introducing the autonomous cell to the original MSF may not be easy as we expected. So need more the work. And also the pandemic, this is very interesting, but it's underspecified. And I'm not sure our implementation is correct or not. So Tero told me that there is the effort to rewrite the text of the 802.50.4 document about the pandemic feature. So I'm very looking forward to new text. So this task is now the tracked as a CID 93 in the group.
You have a question from?
No, actually, I was going to respond to that. So there are given it. We are going to be discussing that next week. I think they have already done some of the work, but they haven't finished all the TSCH. There were so many, items on the TSCH, so they have been going through them. And next week we are going to be processing them. IEEE is meeting here next week, and I think we have 6 or something like 2-hour sessions to work on those items. So we hopefully, by the end of the next week, we will have some solutions at least for the TSCH stuff.
Tero, can I ask you to share those, what is shareable with the group?
Yes, actually, all of the IEEE documents are in the mentor. As you see, this, link that is there.
Yeah.
Actually, and there's this comment database, which is big Excel sheet, and it has, all the comments and all the resolutions to those comments.
Yeah.
So it's you can always go there and check it out.
Okay. So you're asking Yach to go there by the end of next week?
By the end of next
And
week,
seeing
there's
that.
probably going to be about 3 or 4 versions of that data.
Okay.
Because we usually do sort of work for the full day,
Yeah.
and then the end of the day, upload the latest version so that the next day people has all the latest these kind of resolutions already there. So.
Okay, thank you. Please.
Thank you, Tero. I will check.
Yes, one minute.
One more question.
Yeah, how many nodes were in the network which you have simulated? I mean, using the MSF.
In the preliminary the simulations, we have the 13 modes in a random topology.
Could you please state your name?
Yeah, Lijo Thomas. Lijo. Yeah. So I didn't get it. How many? 13 or
30. 30.
Okay. So do you feel any difference when you run the same thing on the open mode or the hardware?
Not yet. I've not yet done. But the TankFei will show some lessons from the real open data system implementation. The presentation. Yeah.
Okay. So one more clarification. How many hops you have? I mean, 5 hops or more than?
So that's so now we are conducting the actual evaluation right now. So when it's ready, so we can share the details with you.
Okay.
Maybe I can show something in my experiment result. I think those I could answer.
Yeah, thanks. Okay, there's one more.
Hello, yeah,
So this is
Hello, yes, this is
Please.
Yichao from Toshiba. Yeah, so I have actually another question regarding with the simulator. So when we're using the 6TISCH simulator, can we like generating our own topology, or we have to use?
sure.
See-
You can
Yeah. So we can
you
generate.
can
our-
implement your
Right.
own topology. Yes.
Okay, and you mentioned this connectivity trace based on the real deployment testbed you have. I think this is a very useful feature. But say if you generate your own topology with say nodes with the transmitters and the receivers may have different distances in between compared with your data get from testbed. Would that the connectivity trace still work?
Sorry. So I dropped something.
Yeah. So you have this connectivity trace model, which is I think you built based on the real testbed you have, right?
Yeah.
But that testbed should have like a fixed topology, with a certain distance between the devices. But if we generate our own random topology with different distances, would that connectivity trace model still work well?
Okay, so connectivity, so that it's not a model. You use that the measurement value instead of the calculated, let's say the RSSI or PDL value by the radio propagation model.
So maybe again, I can try. I see yet you're struggling to hear. So I know the simulator that he's talking about. So it's either a model where you position virtually different modes and it will tell you the quality of the links. That's one option. The second option is you scrap this completely and you replace it by replaying connectivity traces that have been recorded before on deployments and test beds.
Okay, but they are fixed topologies.
And it's a fixed topology, and so I don't know how many there are, but there's a database of traces coming from all the IoT lab deployments, some of the deployments in different countries, and so it's kind of a database of scenarios you can play with.
Okay, cool.
But it replaces entirely the models.
Yeah. Okay.
Thank you. So the last one is just for your information. I've just I updated the flowchart that I showed in the last IETF meeting. So just for information. So thank you. That's all my presentation.
Thank you so much, Yach. Any further questions for Yach? If not, then let's move on to Teng Fei's presentation about experimental evaluation.
Yeah.
Oh yeah, sorry. I forgot to ask the important question. So, Yach, I don't know if you're still online, but would you say in Appendix E of the MSF draft, there's a list of lessons learned basically from your exercise and what Teng Fei has done, what other people have done. Is everything you noted in there? Meaning, if we resolve that, the Appendix C, will you be happy, or do you have more things you want to, suggest changed in the draft?
I think I will be happy.
Okay.
I may find something in the new evaluation, but I think that I already gave all I have right now.
Okay.
Thank you.
Perfect. Thank you. Teng Fei, the floor is yours if you can hear us.
Okay, great.
Yeah.
Can you hear me well?
Yeah, we hear you perfectly.
Yeah. Yeah. I will present on the first slide. Hello everyone, this is Teng Fei and from INRIA Paris. I'm going to present the experimental results. So since the first time we have the MSF, we did this implementation in a testbed in the IoT site, but since the testbed is deployed in the underground parking place, that is not the realistic cases when we do real deployment. So to test the MSF performance in the real scenario, so we built our new testbed called Open Testbed, as shown in the picture. So Open Testbed contains 20 OT box. The OT box is showing on the first picture on the left, and we have 20 of those OT boxes deployed in the INRIA Paris office building. So for each OT box, it contains one Raspberry Pi, and with 4 open mode B connected through the USB port. And so for the Raspberry Pi, it's running a Python script, and with this script, they allow the users can reprogram modes, reset modes, and also interact with the serial port from the modes, like getting the debug information. And the scripts is open source, and it's showing in the link showing on the slides. So everyone can use those testbed and deploy their own or using the testbed we provided. So for the architecture of the testbed, we go to the next slide. So for the architecture of the testbed, it's based on the MQTT the communication. So for each OT box, it will running this Python script to connect to the MQTT broker. And on one side, we have the Node-RED console on sitting on the IBM cloud. It will provide a GUI interface, so user can trying to do the reprogram modes, reset those actions through the interface. And in another hand, the user can use the API provided by the Open Testbed to interact with the Open Testbed, doing the same thing. And for the architecture, the whole testbed is running on a separate network from INRIA site, so everyone can connect to this internet. And also, this internet is running on 5 GHz. So this would be avoid the interference from the testbed itself to the network. Next slide, please. So for the picture showing these slides is like what where we deployed our OT box. So each point in the figures is a OT box, and the point with the labeled with the green items is where the office of INRIA is a room for the office, and the blue one is for the meeting, and the red one is for public area. So the OT box is deployed in the office building. So for me, I was sitting in the NA102, where Jonathan is. It's also there. So this testbed is really deployed in the real scenario for a office building scenario. So with those testbed, we are going to have the result for real scenario. Could we go to the next slide? And we implement the 6TISCH through the OpenWSN project. OpenWSN is an open source project. It implements right now the 6TISCH the whole stack. And recently, we just released the 1.22.0 version. And with this version, we have the open mode support for 2.4 GHz. And because open mode has 2 radios, so we have both ports right now. For this result I'm going to show we'll be only using 2.4 GHz. And also, this release contains a tranche of feature which enables the nodes to have a 100% serial communication with the modes. And as well, it implements the MSF draft. And also in this release, we have the fix the box, which is pointed out by Christine, I believe. And with this, we have some work on our implementations, and right now those bugs is fixed. And as well, those new release with the new release, the user can upload the firmware they just compiled to upload to the testbed. On the right side of the slice is showing a screenshot after all the nodes are flashed with the OpenWSN 6TISCH implementation. We have totally 76 nodes deployed on beside 2 buildings. Could we go to the next slide, please? So for evaluation the 6TISCH implementation, we we're running with the Open Visualizer. So with the Open Visualizer, it can connect to all the mode through the testbed and getting the information from the mode, who is going to send a debug information through the serial port. And as well as I can send command to the mode. For example, like set one mode as a degroot node. And also, because the Open Visualizer is trying to receiving the debug information from all the 76 modes at the same time. So we optimize the Open Visualizer, trying to get all the information updated in time. So now it supports the 76 modes, sending one packet every 100 milliseconds. So with those features, we can start to evaluate what's the performance of the 6TISCH. And also, as well, the implementation of 6TISCH and Open Visualizer both are open source. You can get all the code from the link showing on the slides. Next slide, please. Okay, so now I got the experiment results as shown in this slide. As you can see, this is the routing topology after running the 6TISCH stack. It's totally 38 nodes. Why is 38? Because we deployed this mode in 2 buildings. Almost half of them are out of the range of the one building. So it's basically form a network through all the modes in one building. And for this topology, we can see the maximum hop is 4, and most of them are stay in first or second hops. And in the next slides, I'm going to show the end-to-end reliability of each node. You can, yeah, thanks. And for the result, first we configured the implementation to using 3 retries. So which means that if I transmit 3 times and it's still not able to transmit out, then I will drop the packets. And the result showing on the right side. So you can see almost all the nodes has a 100% end-to-end reliability, except the mode B618. So after I checking the source data from all the packet it received, I see there's one period in the middle. It's missed several packets. I believe this is because during the splitters forming its routing, it's choosing a bad neighbor with a lower rank, and it tries several times and it failed, and then it will change back to a new parent, and then those packets in between will lost and makes this a non-100% reliability. I think this is an implementation issue. We can trying to maintain, still keep those packets in queue, and once it changes the parents, it can change the destination and trying to resend to the new parents to save those packets. So I think this is the reason why one node is not 100%. Okay, you go to the next slide. Yeah. So through the implementations of the MSF, here's the lessons I learned from it. First, I think I got the similar result with Yacht for the currently MSF01, and here's some comments I have. Some of them may be the same with what Yacht is presented before. First is we have in the MSF01, we have the probability broadcasting on EB and DIOs, and this makes the synchronization of the modes take longer, depending on topology. I think this is reasonable because
Yeah, you have a
I'm
question.
sorry?
Yeah, you have a question.
Okay, please.
Okay, it's George here.
Oh, echo.
Yeah, I can hear you.
Why we have a-
Hey, how's it going? Yeah.
Congrats for the experiments and the results. They're pretty nice. I have two clarification questions.
Mm-hmm.
The first one is if
There's
the
a
traffic
huge-
comes only from the lift devices or even the relay devices act as a source, like all devices, all 37 out of 38 they transmit, or only the lift devices? That's my first question. And the second is, what is the traffic? It's a CBR, I mean, bursty, and if it's CBR, it's one packet every how many seconds or minutes?
Yeah, thanks for the question. So for the first one, I think you are asking like why the number is 37.
No,
Assume.
No. Whether do they all transmit? Do they all generate data, or are only the leaf nodes generating data?
Yeah, all the nodes except the DAG root generate the data, the application data.
Okay.
And at what speed?
And the speed is each node will generate one packet every 1 minute. This is on the application layer. Meanwhile, each node will also have the keep alive packet, which will transmit every 20 seconds. If there's no traffic in 20 seconds, it will transmit a keep alive, which is local. Yeah.
One more minor question. What was your slot frame size?
101.
Okay. Thank you.
Yeah. Okay.
Yep.
So I resume on the last slides. For the second point, in my implementation, one node can hear kind of more than 10 of the nodes. And in that case, if I reserve automatic cells, TX cells to each neighbors, it will cause my schedule overflow problems. Though I can increase the buffer of the schedule, but I think that's not a good solution. And as well, the TX automacy is the CSMA is in CSMA fashion. So it will, which means that the application package also could be transmitted on these cells. But since this there's a lot of other also traffic on transmit on the siblings, and this will cause sometimes the IPv6 packet dropping. And the last one is a similar, is the same what Yash has presented previously. And according to those comments, so I have some proposals for the next version of the MSF. The first is I think each node can only reserve automatic cells to their parents, only one. And so basically for each node, it will has 2 automatic cells, and one is reserved as a TX RX shared automatic cells, but only to the parents. It's a unicast cell. Another one is reserved TX RX non-shared automatic cell, but it's an anycast one. So in this case, the node will still sending the 6-top request on the the automatic unicast cell, and for the parents, when it's trying to send the 6-tops response, it will transmit on the automatic cell, which is anycast. You note that the anycast is not shared, which means if the parents' 6 response failed because collision, it will transmit immediately next cell. It won't back off. But for the children who apply that, it will back up. I think this is a reasonable, this will accelerate the 6-top transaction to success, because in the previous experiments, I was looking at these issues. It takes ages for the children to get to the 6-top response. And another one is I want to bring back the managed TX cell before we merge automatic cell or autonomous before we merge ASF and MSF together. So, which means right now we have the autonomous cells, and then after it's installed, the first thing is using this autonomous cell to install another TX cell for later the application to transmit. So in this way, we can separate the application packet from the autonomous cell to increase the reliability, because it's not in contention fashion. And with those settings, and in current MSF 01 version, we are seeing sending the EBDLs once it has the cell. I think we send EB and DLs after we have the one managed TX cell, but I think we can still sending the EBs even before we have a managed TX cell. So for that case, the EB will help all the nodes to be synchronized as well. It won't influence the node like building its routing topology before it's stabilized. Yeah, so this is some my proposal for the next version, and that's it. Any questions?
So some remarks from me. So same question as for Yach. Does the Appendix E contain all the recommendations that you're making, or are there some that you have discovered since, or that you want to change?
Yeah,
is Appendix E complete?
Some of them, yes. Some of them, no. So I think for the next version, we will merge both the recommendation from the current and the one in the appendix E section in the current MS01 version.
Okay, it's really important that you raise those issues that are not in Appendix E on the mailing list, so that they can eventually make it into MSF.
No.
Simon, you had a question?
Yeah, so I'm just trying to understand the problems you were having with the autonomous cells and the proposals you have. So I feel like the main issue you're having is that you end up with a lot of TX cells in your schedule, right?
Yes.
Yeah. So maybe what we could do is think about the conditions when we're actually installing the TX cells. So maybe we don't install TX cell for each neighbor on the table. Instead, we could just install TX cell on demand whenever there's a packet to send to a given neighbor. So the idea in the autonomous cells really is that you just have one cell to listen, and everybody knows what that cell is because it's the hash of your MAC. And then whenever you want to talk to someone, you just hash their MAC. So I agree that in our current draft, we may take too much resources with having one TX cell for each neighbor.
Mm-hmm.
So let's just have it on demand. Whenever you have a packet in queue for neighbor B, then you add a TX cell for neighbor B and you send it over there. And then you can even have a timeout for that cell.
Yeah, it's more like I agree. It could be several proposals, and I think that's one of them.
Wait,
yeah.
There's something I don't understand. If you proactively install all these TX cells, you're not using them anyways until you have something to say. So what is the difference between, Simo, what you propose and the current state? Is that we prevent installing additional TX cells when one is already in place at that time slot? Is that the thing?
Yeah, it's the only thing. Like, just save some memory on the schedule side.
Okay.
Because that seemed to be the issue, right? Thankfully.
Yeah. I don't know. So in that fashion, it's like in my schedule, I will have the TX cell like one time it will appear here and later appear in another place.
Because I mean, as Thomas points out, I think there is no difference in terms of what's happening on the air. It's really just about how you manage your schedule internally. It might even be up to implementation how you do it.
Yeah, I think it's the same. What you propose and mine. So you are saying propose the install the cells on demand, and actually in the most cases the children will actually only talk it to their parents. So I think mine will be the same.
Yes, guys, please let's take it to the mailing list because we are running out of time and it's time for Manisha to. Last question, maybe?
So, one more remark. Have you tried consolidating your findings with, I know that Simon did a bunch of work on the similar things. I know that, Yaj did. Did you try to consolidate those things yet? Are you finding the same issues that Yaj, for example, had? We haven't tried yet.
Yeah. I just more like talk to them privately and listen what they learn, and then at these experiments I can have similar results.
Yeah, we can. Yeah. Pascal is proposing to do an interim dedicated for this to have some high bandwidth to talk about this. Manisha, you had a last question?
So Christian Hoffner from Jabber. The question is, what about installing TX cells only to ripple neighbors? So I guess we could.
I'm sorry? To install the TXL to
ripple neighbors, only to ripple neighbors. Ripple parents, I suppose, yeah.
You mean how or why? Because
he's proposing another alternative is to install an autonomous cell only to a node's ripple. He says neighbors. Do you mean parents and children? Yeah. Okay. So let's have an interim to discuss on MSF specifically. To have some high bandwidth, venue, but I want to stress how important what you guys did, or though is because we getting almost live feedback from our standardization work. So that's very, very cool. So thank you so much for going through the exercise of doing this.
Yeah. Thank you.
With this, I'd like to move on with our agenda. Marisha presenting the minimal security draft. Yeah, go for it.
Yeah. Okay. Thanks. Yes. So we we had a working group last call. It was before Montreal in July, I suppose. And ever since we published 2 versions of the draft, basically resolving all of the issues that were raised during the working group last call. And during the working group last call, we had a lot of reviews. We had 7 reviews from Yoran Tero, Xavi, Klaus, Jim Schad, Teng Fei, and William. And then Thomas did a review yesterday also, which is incorporated into the 08 version. So my goal of the presentation today is basically to go through the major issues that were raised during the working group last call and to present the contributions to the group. So I said I will present major issues that were resolved. There is a whole bunch of other issues and editorial changes that were made to the document. And please follow this link to see all the issues that were addressed in the latest 2 versions. So the first issue that I will present is on stateless proxy. And we had a lot of discussion. This was with Tero and also with Klaus from Core, and also Yoran Salander brought up this issue. So essentially, so this work has now been outsourced to Core. Klaus published a draft which has just been adopted in Core, which defines, which basically extends the base co-op header with an extended token in order to support our use case for having a stateless proxy. And you can see the format of this new co-op header on the right. Do I have the later? Yeah. On the right, and basically just some reserved bits from the base co-op header are now used to encode a longer token. And what we did in minimal security is that we completely removed the definition of stateless proxy option that had the same purpose, basically carrying a longer token that would carry the state of the proxy. And now we have a section in the configuration part of in the application layer configuration, basically recommending the use. Recommending the JP to operate in a stateless manner. And to operate in a stateless manner, what JP needs to do is basically just wrap the state that it needs to keep per pledge into a co-op token. For this, it can use the co-op token as defined in RFC 7252, or if this doesn't fit, it can use Klaus's draft that will go for working group last call quite soon. And basically, with this, we now have only an informative reference to the core draft. Then also, after long discussions with Tero, this is now the recommended behavior. We also have a disclaimer there on the implementation stacks where it may be difficult to implement the statelessness at the joint proxy. And I mean statelessness throughout the whole stack. And there we note that in these cases, the proxy can operate in a stateful manner, but this comes normally at the price of an additional DOS vector. So the second issue is on the use of confirmable co-op message for join requests. This is something that was brought up during a core interim meeting sometime this summer in August when discussing the operation, also in coordination with Klaus. So basically, previously what we had is that the pledge would send a non-confirmable request in order for the joint proxy to forward the request as non-confirmable, and to not to keep any state for retransmissions at the proxy. So later when discussing this, we came to know that basically we can, the proxy is not required to forward the message in its original type. So what we do now is basically we simplified the document by requiring the pledge to send a confirmable co-op message, but then proxy forwards it as non-confirmable, and therefore there's not need to keep state for the retransmission. The retransmission is then completely handled by co-op, and what we need to do in the minimal security document is only override the values that the co-op retransmission mechanism uses for our use case, which is join, and I give here the default values that we recommend on using. Third major issue is a bandwidth cap at JP. This is basically as JP forwards traffic coming from unauthenticated nodes. This traffic consumes the bandwidth upper up in the mesh. And basically, we discussed also, I think, with Tero, this was one of the comments, on basically limiting how much traffic the JP should forward when it operates in a stateless manner. So basically, a good thing with this was also discussed during the core interim meeting, was that co-op already provides the congestion control mechanism, and basically two parameters. One is nstart, which is useful for the proxy that operates in a stateful manner, and basically nstart just specifies the number of requests, number of requests or number of ongoing transactions with a given endpoint. So basically, by setting nstart to 3 at the joint proxy will never forward more than 3 requests before either getting a response or timing out by some mechanism that is not defined in co-op. And the second parameter is probing rate. That is useful in the case of a stateless proxy that is specified in bytes per second, basically, and it's essentially a bandwidth cap that the proxy should not exceed when forwarding to a given endpoint. So the good thing about this, when we use this, there is absolutely no need for any additional lines of code. All of this is already in 7252, and we need to define values. So for this, I will now present what we have in 08, and at the end of the presentation, after some discussions that we had during this week and also today, I will present an additional proposal that we can do. So what we have in 08 is basically this table with default values of co-op parameters for our case for join, where we specify that nstart at the pledge should be normally 1, but at the join proxy should be 3, meaning that the join proxy can forward at most 3 requests without getting a response. But then for the stateless case, where we need to specify the probing rate, what currently stands in 08 is basically the equivalent in bytes for these three, for the n start of 3. To calculate that equivalent in bytes, I had to make some assumptions on the join request message size, etc., etc. So that basically results in a probing rate of 12 bytes per second at the join proxy that should be averaged over a window that is 10 seconds long, act timeout. So I don't have time now to go into the details of this, but please bring the question up if you're interested, or we can discuss after. Essentially, I mean, with this 12 bytes, we consume around 18% of the available upstream bandwidth, assuming one cell with preferred parent on the path to the 6LBR. And this can and should be higher. But as we discussed also on the list, this is something that the JP might not know. So you will see now in the proposal, we basically propose to make this configurable by the JRC, so that the JRC just can configure the joint proxy with a given cap, depending on the current status. For example, if network is forming, or if there is an attack, or etc., etc., we give basically this control to JRC. So this is the proposal for 09. Yes.
Just to think, I would really like to see the work on the mailing list, because we would like people on the mailing list to be able to come out and give feedback. The other thing is, the other thing is, you know that we are working on getting from repo the capabilities and the saturation at the root, going down through the DIOs. So we don't have that specified yet, so you cannot point on it, but you could have some loosey word which say, okay, if you have some indication, e.g. from repo, about the saturation of the node of the root, which is basically the bandwidth that is available all the way through, because the root is the gating factor, then you can use that to automatically tune, and that's implementation.
So you're saying if the JRC has this,
JRCs would be a slave of the root in some fashion, right? In implementation of that, right now is the root would give this information to the JRC, you get it from the JRC. But you could also directly get it from the root, because we'll soon have that signaled in DIOs. So it's just a matter of wording, keep that open, what the source is.
Okay.
Right?
So yeah,
if you don't specify, if you specify the transport, like you put that in the JRC, say, here's the field. So we'll do it this way. But if you say, oh, if it's available from the routing protocol or something, you may use that to tune dynamically.
Oh, okay, I see. So yeah, but I mean, the intent was just basically to have this as a field to configure the JP, and then
Right.
what value
which is static, then I expect.
Huh?
You figure in your mind it was a static value that the administrator would set?
Yeah, that yes, exactly.
Because what I'm saying is more like a dynamic observation by the root, which will be part of the DIO. And so actually that would tell you not a static value of 3, 4, 5, 6, but oh, if the root is less loaded than that, then you can have so much. You see, so some logic like that.
I see. So basically,
but don't specify it. Just say, hey, you can base. Don't mandate that it's hard coded by the GRC, because it's not necessarily a good idea.
Well, no, I mean, I wasn't going to hard code the value, of course, but I mean, just have a means for JRC to communicate it.
That which is good, and then you can say it can also come from repo.
Yeah. Yeah. So okay, then we should think about this on the on the text, basically. So yeah, this is the intent for 09, basically to introduce it in 09, because right now it's not in 08. This is something that we discussed this week. Then a fourth major issue basically was raised by Chavi. We're missing an error handling section on the QGIP protocol. Basically, what happens when an error is encountered at the CBOR level, at the payload, at the level of the payload of this configuration protocol. And QGIP, when processing, CBOR objects are processed both as part of co-op requests and responses. For requests, it's quite easy. I mean, we just need to transport, we return 400 bad request response. But for responses, it's more tricky, as, for example, you get, so the pledge gets a response, a configuration object, and it cannot process it. So this was a co-op response now. So what does it do now? So what we mandate now is what we recommend basically is that in the next request that the pledge will make to join to the same JRC, additional parameter that should be included in this join request object is basically the error code from the previous attempt to join. And basically through this, I mean, we give some hint to JRC on what went wrong with the pledge. Maybe some parameter was unsupported, so maybe you should exclude it or just help the debugging information. And to do this, we define the new CBOR structure called error, basically carrying the code, the additional information, and human readable text description, and we give like some values for that. Fifth major issue was on AEAD nonce reuse that was brought up by Jim Schad. So basically the case here is that JRC for some reason completely fails and loses all mutable context parameters, for example, the sequence numbers and the replay window. So in those cases, this was also discussed with Tero. We mandate now that the JRs, that the network, if this happens, that basically all the networks that are managed by the JRC must be reinitialized and all the nodes forced to join. But then the problem arises when these nodes rejoin, if the JRC attempts to update the parameters on any of them, and it lost the previous security context with these nodes. And as we don't want to reprovision every node that was ever deployed, the problem is that when this first parameter update message from the JRC to the nodes goes into the mesh, there is an imminent risk of this of nonce reuse basically, and this was brought up by Jim Schad, and Jim was also kind to propose a solution which we now included, and the solution is as follows. Basically, the JRC knows that the new JRC that takes up from the old JRC knows, okay, there's been a failure, there is now the risk of this nonce, the nonce reuse will happen. So now in the draft we mandate that the payload of this request will just padded with a byte string that is generated uniformly at random. And we send this request that will cause nonce reuse to the node, who will detect the nonce reuse as the sequence number will be largely below the one that it expects. So this is already handled by OSCOR, and basically, so what we do is that when the node detects this significant mismatch of the sequence number, for example, just reset of the context one, it responds with this error that we defined, and one special error case where part of the additional information of this error is the next sequence number that the node in the mesh will accept from the JRC. And literally with this, basically, we transport the lost state from the node back to the pledge, and the JRC receives this error, which is encrypted with a new nonce that is not reused, decrypts it, gets the state, and recovers the state, and then it can continue as follows. So this is in the text. I mean, you should probably read the text for the wording. Jim seemed okay with the resolution ever since I did some editorial comments, but the solution should still stand. Sixth major issue was on the blacklist parameters. So Tero was arguing that in case one likely case is that there is a misconfiguration of pledges that we continuously try to join. So basically, to support this, we added the blacklist parameter that JRC can include and send to any pledge or the join proxy. That is just basically a list of pledge identifiers that it needs to blacklist. And how this is implemented, of course, is implementation specific. I mean, many implementations do this in hardware, and but essentially with this, we give control to the JRC to blacklist.
Can you unblacklist?
Yeah. So yeah, that's a good question. So basically, unblacklist would be sending the blacklist that is empty again.
So that means that you always send the full blacklist.
Yes.
It's not incremental.
Yeah, this is currently the case. That's right. So the intent was for the last blacklist value to override the previous ones. But yeah, I would. So yeah, this was the intent. I would need to check the text if it explicitly denotes this, but this was the intent. Basically, take whatever you receive and just configure it. Yeah. Is that okay, or?
It just depends on the number of devices you will have to blacklist, but yeah.
Yeah.
And maintaining addition and synchronization is so full
Yes,
that's
exactly.
probably the easiest
Exactly.
way. You don't expect many nodes, right?
Yeah. Okay. So I'll check. I'll take as an action point basically to check the text and to explicitly state this. This was the attempt currently. Yes. Then the seventh resolution was I think this was Terra's review. Yes. After the last IETF, basically we extended the link layer key structure, and now we support all modes of 15.4. We add an additional parameter, which is key additional info. It is a byte string, it's optional. And depending now on the combination of these parameters that are included, we support different modes. And there is also the mode, the implicit mode, where we essentially, where the JRC acts as a trusted third party, but we do not detail it, how this is done. And basically, I mean, this key can then be used, what we discussed on the list, for additional protocols to bootstrap the keys between, or for future extensions for pairwise keying, basically. So, Tero, could you check just this text if it's all consistent what we discussed? I think because we had. So but this is in 07. This was done in 07. Yeah, 7. Yeah, and then, so there were a lot of other miscomments, updates of the security considerations, uniqueness requirements were explicitly stated, privacy considerations were updated, some overhead optimizations were done, like short address lease time is now encoded in hours, not in seconds. So basically you can specify the lease time only in multiples of hours. PAN ID clarifications that it's not stable. We mandate, so we reverted, we went back and forth with this, but so finally we mandated unique pre-shared keys, but we added a lightweight implementation option appendix that basically details an implementation options where the implementation of HKDF and SHA is not necessary in firmware. And also we removed the network prefix parameter as discussed at the last IETF because we decided not to go into the 6LBR configuration management. And of course, it would be great if people could just see a list of issues or just go through the document for consistency, not for consistency, but if everyone is happy with the resolutions. So regarding the next steps, as we had a lot of discussions also this week and today. The two pending proposals is basically to add this bandwidth cap parameter that the JRC can use to configure JP. And basically, this would just extend that configuration object that goes into the join response or in the parameter update message. And then the second one was basically we just noted that there was a remnant on this 6LBR management. Basically, we still have a network identifier that can be returned as part of the join response. And this only made sense in case of 6LBR joining. And to bootstrap 6LBR completely, I mean, it needs much more parameters, so we decided not to go that way. And so the proposal here is to remove the network identifier from the join response, and it requires the 6LBR to be provisioned with the network identifier before it starts advertising. So these are two, I mean, short modifications. I mean, I can probably do this tomorrow. And after that, we can discuss on the list. So this would be 09, and I'm just request here input from the chairs on the next steps for the document.
Well, for just the proposal, like I said, you need to go to a mailing list, just summarize that, just like you did, and so people will react like I did, like the root could also give you hints. Now, for the other points below, we have Suresh in the room, so I hope chance to make. Because basically, once you're done with this, you're ready for last call, right? But
So-
then you've got this dependency.
So do we need another last call, or how it goes normally? Because we had the last call in, when was it? In July. Yeah.
So the history about this is we had a last call. You had lots of reviews, lots of change that you just in fixing that you realize there's two little things that you still want to change.
Yes.
Because you're going to change that, you have to do the proper way. So that means discussing it on the mailing list, getting some feedback, some ideas, implementing it into the draft, and then we do a short last call at the end.
Okay.
Because we certainly don't want to ship something where at the last moment something slips in and there's no
That's
proper review of
That's
that.
fine.
But I for having read the draft just very recently, these things are tiny little changes. I think we absolutely want to do the last call, but we'll keep it at a short last call. The question then is, then this thing is ready. The question, of course, is the OSCOR kind of blocking the.
Yes, so regarding OSCOR, yeah, and this probably Suraj that can, but I mean, right now OSCOR still has a discussed to our knowledge, and the result ad hoc also has in progress since Prague.
Sorry, but ad hoc is not in this.
It's not this draft, yeah,
yeah.
but it's important for zero touch.
Let's talk about OSCOR.
Okay.
Yeah, serious question. So a couple of things. First, for the last call, like Thomas said most of what I wanted to say, but one additional thing, in case you want to do a short last call, you can limit it to like the changes that are there. So not opening up the whole document for comments again, if you want, okay, if you want to keep things simpler, but that's fine, either if you want to do it. Oscar, like I had a chat with Alexei, so he thinks it's progressing, like he had a chat with Eker about this as well. I was going to talk to Alexei, but we kind of kept missing each other because he had to present now at Acme, so I couldn't really get to talk to him. But this is something I want to talk about tomorrow. Like we have an IESG wrap up, and I will talk about this tomorrow to him. And but don't block this document because of Oscar. Okay, so that's like my responsibility. I'll take care of it when the thing needs to go. So like when the working group is ready to push it. And if Oscar changes significantly before it gets approved and you're worried about it, we can bring back the document to the working group and do stuff. But I want to just go through the process like when you're ready to go. So I don't want to hold the document here.
Perfect.
Okay.
Perfect. Yeah, this is great. Thank you. Thank you so much.
Yep. And then just the last point is basically on the future extensions. I mean, Michael, I think he's in ACE.
Yeah, he's in ACE. Yeah,
he's
he
in
texted us.
Yeah, because we had a collision. So basically, this is on zero touch. This is regarding ad hoc. So
yeah. So we're going to go to ACE after talk to the ACE chairs about ad hoc. No input yet. We'll have to discuss.
Okay. Yeah. So that's all from me.
Great. Thank you so much, Marisha. Okay, we're over our official time, but we built in a 15-minute buffer, which is exactly how much Simon needs for presenting this draft. So we're now entering the non-charted work, new work. Simon, if you can hear us, the floor is yours.
Yep. Can you hear me? Yeah.
Yep. Perfect.
Yeah, thank you. So yes, I'm presenting that new draft, which is a proposal. The main author of that draft is Marco Tiloca. You might know. He wasn't really in 6TISCH, but he's very involved at IETF and security. He's now sitting in ACE. That's why he's not presenting, but he's actually in Bangkok. So if you want to have a chat with him, you should manage to meet him. He's been also involved in core, etc. And so what that draft is about, so it's a security draft. And it's about a selective jamming attack and a mitigation against it. So the motivation is that in TISCH, the cell utilization pattern is predictable because you have slot frames with a given schedule in them and they repeat periodically. And so an adversary can easily derive communication pattern by listening over a long enough period, which actually consists of several slot frames. And after that, it can extract the full schedule of a given victim node and then do selective jamming against it. And why it would do selective jamming is for two reasons. One is to be unnoticed. That's for the selective part, and also to save power. So if your attacker needs to be on battery. So that is the motivation for that work. So what makes the attack easy? There are a number of properties that you have on a 6TISCH schedule. It's periodic, and here by periodic we mean a period of slot frame length times channel hopping sequence length. So at that period, cells repeat on the same actual frequency, not just channel offset. There is the usage property that tells us that as long as your slot frame length is co-prime with your channel hopping sequence length, then all the cells are going to be used during one of the periods above. They're going to be used uniformly. Then you have the offset property that states that all of these cells basically repeat with a given fixed offset over the slot frames, and the predictability property where you can predict a sequence of channels once you have figured out a time slot. So below are a number of equations that I'm not going to detail now, but what that really tells you is that once you've figured out the physical frequency of a given at a given time and channel offset for a given cell, you can then infer for other cells which frequency they're going to run on a given ASN. I'm going to exemplify that a little bit more in the next 2 slides. So the attack outline is the following. So you start at a given slot frame. It does not need to be slot frame 0, but you will count it as 0 in your internally, and then you pick a frequency. So let's say you pick frequency 1, and then you start listening, and you listen for 1 period. And period here again is slot frame length times channel hopping sequence length. And then from that, with the equation of the previous slide, you can derive the full schedule, basically. So you know exactly when and on which frequency the node that you are targeting is going to transmit. So you have that full schedule, and you can selectively jam it. And if you go to the next slide, you'll have a visual explanation of that. So thanks. So here is a schedule. You have a slot frame length of 3 and a channel hopping sequence of 4. So we're going to keep listening for 12, 3 times 4. And in that example, the node, the attacker picks frequency 1 and is going to listen on frequency 1 for 12 slots. And what you see on that schedule, in each cell, you see F equal. That means the actual frequency where the cell is actually executed. So if you start listening, here we start listening at ASN 3, and we listen for 12 slots. And we notice a few cells that execute on frequency 1. So there is one on ASN 4, one on ASN 5, and then one on ASN 6. And then it will repeat after 12. So that is for the scanning part. So you do that listening on frequency 1 for 12 slots, and then you know the full schedule, and you're able to selectively jam it from now on. So that is what the attack looks like. So if you go to the next slide, I give you the overview of the solution we're proposing. So the idea is to prevent the attack by construction. So we're basically going to do shuffling of our own schedule. So we do permutation of our own slot frame in the time and in the channel offset domain, both. Well, in the time domain, it is optional, and in channel offset domain, it's not. And that is done locally using a secret. So if you go to the next slide, I can talk a bit about the secrets that we need for that. So we have actually 2. Next slide, please. Yeah, thanks. So we have 2 permutation keys. One for the time domain, it's KS, and one for the channel offset domain, it's KC. And then we also have counters for the time and channel domain. But the counters is just internal accounting. It's just a variable internally, so it does not matter as much. But the permutation keys are secret that we're going to obtain at the join, at the secure join using CodeJP. So if you go to the next slide, it's a bit more detail how this solution works.
Simon, you have a question?
Hello, Simon.
Oh yeah, sorry.
Yeah, it's fine. This is Yichao Jin from Toshiba. So basically, I think it's a very interesting idea to reverse engineer the TSCH pattern. But I still cannot really understand the rationale behind to use it in the kind of attacking scenario, because basically, if I'm a smart attacker, the purpose of attacking is focusing on the entire network rather than a particular node. Yeah, so that's usually what happens, right? You are targeting for the entire network. So
well, you could imagine both cases, right? So I could, and plus you could do that on the entire network too if you have enough attackers. So
yeah, so if I can know the so for example the content. So if you do selective jamming, for example, the purpose is why you do select jamming, because you want to you want to jam some content, right, from that particular node. But if you already know the content, which means you already hack into the network, then you know everything.
no, you want to basically prevent a node from communicating altogether. You want to disconnect it. So you're jamming every single transmission of that particular node.
Right, but in that sense, do you need to know the particular channel and time a node is transmitting rather than you just keep on jamming it?
Yeah, so the advantage of doing it selective is to be unnoticed and power efficient. It's a bit more secondary, but it's to be unnoticed. So nobody will notice there's an attack going on. It's just, oh, that node can't seem to talk anymore. Why is that? But you can't notice, oh, there seems to be a jammer there.
But would the parent node can also detect that? If the parent node didn't receive anything from a child node?
So the only thing it can notice is that, oh, that particular node cannot talk anymore. But it's not as obvious that it's a jamming attack as it would be if you would be just jamming aggressively.
Yeah, okay. I mean, from my point of view, is basically, yeah, the whole network probably will be the target. Probably it's more makes sense.
We're getting out of time, guys. We're past the hour.
Yeah, so I mean, just last.
Interesting discussion on the mailing list. Unless people want to stay in the room, I think we don't have to give it up. But...
So wait, sorry.
Okay.
Yeah. So I'll conclude here. So at each slot frame, you're basically going to schedule for the next slot frame. So if you go to okay, you're on that slide. So you first permute in the time domain, and that one is optional, and that's optional because we're well aware that some schedules might have end-to-end delay that they need to guarantee. So if you would shuffle the time domain, you would lose the properties. So we make that part optional. But when it can be enabled, it gives you extra added resilience against the attack. And on step 2, you permute the channel offset. And these 2 permutations are done using the secrets that I mentioned in the previous slide. So you have that secret obtained at join time. So next slide, please. So for the key provisioning, so how we get the 2 keys, we get them at join time, as I mentioned before. The proposal is that it's an additional cozy key set in the join response. And that set has 2 or 1 key. So if it's 2 keys, then it means you're going to permute on both the time and frequency domain. If it's 1 key, it means it's just going to do the channel frequency domain. And we still need, by the way, to update the draft to the new minimal security draft and the core and the cozy set. And next slide, please. So to summarize, we introduced that attack, and we want to hear if the working group is interested in having mitigation against that attack, and if so, we also have a proposal for mitigation that has good property that it preserves the collision-free and consistency of your schedule, etc. It has no communication overhead, so it comes quite cheap. So it has all these advantages. So what we really want here is to get feedback on if the group is interested in these. And yeah, the next step as well, we have that update for the new minimal security with the cozy key set. Thank you very much for granting some time on this today.
Yeah, so we still have 2 minutes. So I want to make, so when I read the draft, I thought, I'm still not 100% convinced that it is a neat little trick, but how real is that attack? I mean, we can imagine all kinds of things, and so this is is it a solutions looking for a problem is what I'm asking myself. But actually, the previous discussion, I can see a little bit better in the sense that this attack would allow you to basically have one node disappear from the network and not just have a signal generator blast energy and just cut the wire basically. So I'm a bit more convinced now. Just wanted to raise this on the mic.
Thanks.
Terukimine, I have a question. How do you actually, if I understand correctly, you shuffle the channels based on the keys that the joining node doesn't know, for example, or the attacker, which means how do you actually join that kind of network? Because normally you do this, that you have this one fixed slot that is announced in the beacon, and that has to be there. If that one moves somewhere.
Yeah, it's a very good point. So it's something I haven't mentioned today. So we do it per slot frame. We don't do it on every slot frame. So the idea that you wouldn't do it on the minimal cell, so that joining remains possible.
Well, Thomas, the attacker doesn't know the network, it doesn't have the keys, right? So you might indicate those numbers in some encrypted portion of some of the messages so that you would learn it during join. I agree that with EVs, it will be hard.
No, but
so it's actually not that problem. The problem is that when you see the first enhanced beacon, that's in clear. Of course, you have to, and it doesn't matter which channel or which frame it comes in. You just see it. But then you need to know what is going to be the the initial schedule. Where is the one slot that you can talk to the joining node?
Yeah,
and that needs to be same.
Absolutely. That is why we do not shuffle the minimal cell. We do not shuffle the slot frame 0.
So you don't shuffle all the slots, because that might not be the first slot, because there might actually be multiple slots there.
So it's per slot frame. So slot frame 0 we do not shuffle because it's the minimal slot frame. Right?
Thank you, Simon. Any more questions for Simon? No. Any other business you want to discuss before we close the meeting? We're at time. Okay, I hear nothing. All right, thank you so much. Meeting is finished. Thank you.
Bye.
Bye.